Okay. So what we know about marginal costs, how to find it, what we should do. Ivan, please.
Isn't it a derivative of the total cost?
So it's the derivative from total cost. So it's
500 plus 2Q.
Ivan, please continue. What about average cost?
And that's harder.
On average, how to find?
We divide by Q.
Total cost over Q. So divide this function.
Yeah.
1000 over Q plus 500 plus Q. Yes. Then, okay, Anastasia. Then please, how to find average variable and average fixed?
Average variable cost is variable cost divided by Q. So if we know that fixed, we have variable and fixed cost, and we should probably.
Okay, let's find fixed costs first of all. It's what? Yeah.
It's
fixed, constant, yes?
You mean like
1000 is fixed cost?
Yes, 1000, exactly. So by definition, we have fixed costs even if we do not produce anything, yes? So it's total cost if quantity equals to 0. Put here 0. Yes, it's 1000, it's constant. And everything else, it's variable cost. Total cost minus fixed costs. It's everything else. So this is variable cost. This is fixed cost. Yes. Variable costs, they depend on the quantity that we produced. You see, this is the function out of quantity. Yeah, easy. So what about average variable? Tell me.
it should be 500 plus Q.
Yes, and average fixed?
It should be 1000 divided by Q.
Fixed costs over Q, it's 1000 over Q. Yes, thank you. So let me show you the graph, how to draw all these lines. I'll start from here. Horizontal axis quantity, and vertical axis everything that are in money terms. Everything that is in money terms. So we always start from marginal costs. Marginal costs. Let's see. Let's see. 500 plus 2Q. It's linear function with positive slope. You see, linear function with positive slope. So if quantity is equal to 0, marginal costs are equal to 500. Yes, so we start, if quantity is equal to 0, marginal costs are equal to 500. And then a line with positive slope. Marginal costs, easy. Then, next, we draw average variable costs. Average variable, always. And as you see, it's 500 plus Q. Something similar to marginal costs, but the difference is only in the slope. In marginal 2Q, in average 1Q. Yes, Q. Also, linear function with positive slope. It starts also from 500. If quantity is equal to 0, average variable costs are equal to 500. And you know it from the lecture that average variable costs and marginal costs, they start from the same point. Yes, so we start from 500, but here we have more flatter slope. Yes, flatter slope. So you can check. You can check for yourself if you do not understand about slopes. for example, if quantity is equal to 1, average variable will be 501 and marginal will be 502. So marginal costs are higher than average variable. Yes, like this. Average variable costs. Then next, average fixed costs. What is the graph to such function? 1000 over Q. Please tell me.
Hyperbola.
Yeah, hyperbola. Yes, you know this. 1000 over Q.
Hyperbola.
So if quantity is almost 0, average fixed costs are equal to plus infinity. Yes. If a quantity is very, very big, yes, average fixed costs are almost 0. So we start, for example, from here, from infinity, and almost reach horizontal line, but never intersected. Yes. Okay, it's average fixed costs. Then the hardest is average costs. Average cost. That's why it's the last what we draw. We know that average costs, they are combined by average variable and average fixed. Yes, you know this, that it's average costs equals to average fixed costs plus average variable costs. Yes, and we see this. Here is hyperbola plus linear part. Average fixed plus average variable. You see? So how to draw it? How to draw such function? We know that average costs consists average fixed and average variable. So average cost always greater than average fixed and average variable. So average cost graph will lie above average fixed and average variable. Yes, above. Never intersect. Never intersect. So let me write average costs always greater than average fixed. And average costs always greater than average variable. Here will be like this. So also consider this quantity very, very small and quantity very, very big. If quantity is very, very small, almost 0, we will have infinity plus something positive. Yes, if quantity is almost 0, here will be infinity plus something positive. So we start from infinity, but higher than average fixed because we plus something positive. Then, if quantity is very, very big, almost infinity, hyperbola will be equal to 0 in the limit. Yes, and we will have a linear function plus something positive. So it will be here, above average variable. And minimum of average costs, we know that minimum of average costs equals to marginal costs. Yes. So the graph of average costs intersect marginal costs in its minimum. Like this. U-shaped function. Yes. Here we go to infinity. Here we go to average variable costs. Yes. So guys, please ask about this task questions. Okay. So let's continue. Maxim, please.
I have a question. According to this graph, can we analyze if this firm gets profit or not?
We do not know. It's everything only about costs, but we do not know about the demand function, about prices here, about revenue. We can draw. We can draw, for example, for perfect competitive firm, if price is somewhere like this, if this is constant price and this is the marginal revenue for perfectly competitive firm, we know that we will produce this amount where price intersect with marginal cost, and profit will be the area under price and above marginal cost. This will be the profit. But I think you don't know this to this moment?
Yes,
Or
that's
you
why I
had this
asked.
direction?
That's
Ah,
why I asked.
okay. It's our next topic.
Okay. Thank you.
Елизавета, please, you have question?
Yeah, I wanted to ask if these functions, they are they always similar? For example, like the AVC is always a linear function, or AFC is always a hyperbola, or not?
No, no. I will give you, for example, at home. Consider such function. Total cost equals to core insert, yes, plus 2q square, I don't know, minus 5. And do the same. You see that average costs will be q square. Yes, it will be quadratic function. Average costs. Marginal costs will be also quadratic function. When you take your prime derivative, you will have quadratic function. Yes, marginal cost will be not linear, but quadratic. So it depends on the total cost function. Okay?
Thank you.
So let's continue. Please open the next class, class 6, number 1. In the first task, we will talk about revenue. Today, first task about revenue. A lot of words. Yeho is a small, perfectly competitive manufacturer of cowboy hats. Hence, it can sell as many hats as it wishes at a price of 20. So, perfectly competitive firm for each perfectly competitive firm, because we know that in perfect competition there are many, many firms. That's why each firm is a price taker. It takes price as given. So the price for the product is constant for each firm in the perfectly competitive market. So the price for which it can sell hats equals to 20. The total revenue the firm receives is equal to the price of hats multiplied by the number of hats shipped. Easier, yes? So total revenue equals to price over quantity. And will be equal to 20 multiplied by the number of hats. Yes? Easy. Then, suppose that in the short run, the amount of capital equipment and raw materials that Yeho has is fixed. So we have short run such that capital equipment is constant. And why do we need this information? Capital is fixed and sufficient to produce at most 1,000 cowboy hats. So we have such amount of capital to produce maximum 1,000 hats. Okay, it's from the task. Then the firm can only vary the amount of one input, labor services. So in the short run, only one variable input, it's labor. Labor, variable input. Draw a graph that shows how its total revenue will vary with the shipments of hats. Calculate the slope of the curve you have drawn and interpret its meaning. So, how to draw? Let's see. Here will be quantity, here everything in dollars. Yes, and we should draw total revenue function. But you see that it's linear function with positive slope, yes, with the slope 20. And if quantity is equal to 0, we do not have any revenue. So it goes from 0 and with the slope 20. Total revenue. But how to calculate in calculus the slope? What do we need to do? Who knows?
The slope is tangent from
Yes.
yeah. So we
Yes.
need to how to find tangent. Oh my god. Tangent.
No, okay, it's the slope of the tangent line, yes, to the curve, yes. But here we have a linear function. We should take the derivative, yes. The derivative shows us the slope, yes. It's the slope of the tangent line to the curve. So take the derivative. It equals to 20, yes. How we name in economics? How we name the derivative out of total revenue?
Marginal cost, I guess.
How?
Marginal cost or
Marginal cost? Maybe marginal revenue?
yeah, marginal revenue, yes.
Yes. Yes. Yes. Uh-huh. Yes, it's marginal revenue. Marginal revenue. By definition, it is the change in total revenue when we change the output. Yes, by definition. So marginal revenue, it's the revenue that we get from the last unit that we sell. Yes. Okay. So we explained what is the slope of this total revenue. Then, but what I should also put on this graph, what I forgot, who knows? From the info, from the task, what I forgot.
The limit?
What, please, one more time.
The limit, I mean that we have maximum quantity.
Yes, yes, exactly. So we cannot sell more than 1,000. So stop here. And here will be Q max equals to 1,000. Thank you. Yes. So, okay, good. Next. Suppose that the average variable cost of production is a constant $15 per head, and the fixed cost is 1,000. It's point 2 or point B. Average variable costs equals to 15, and fixed costs equals to 1,000. Illustrate the firm's total cost curve on your graph from A. So what will be the function for total cost? Who wants to tell me? Anastasia, please.
So from the definition, total cost is the sum of average cost and fixed cost and
Very not
yeah.
average, but
Vary and fixed.
so
And also we know that the wait a second, I'm confused. So we know fixed cost. It is 1,000. It is going to be variable costs plus 1,000. And as we have average variable cost, we can say that our variable cost is going to be 15 multiplied by Q.
Yes, yes, thank you. So it's average variable cost multiplied by quantity.
Yes.
Yes, so it will be 15Q plus 1,000. Good. So we should draw it's also linear function with positive slope. Yes. And for example, if quantity is equal to 0, total cost equals to fixed cost, 1,000. Yes. Quantity equals to 0, total cost equals to 1,000. So we start from 1,000. The slope is 15. It's flatter than total revenue. Slope, yes. 15, flatter than 20. Agree? So it will be like this. And also we can calculate this total cost. Also we can calculate these points. But do we need it? Maybe, yes. If quantity is equal to 1,000, total cost equals to how much? 2,500. Yes. No. 16,000. 16,000. And about revenue, if quantity is equal to 1,000, total revenue equals to 20,000. On the graph. So, okay, then what else? How many heads does the firm need to sell to break even? That means to make zero profit. Break even. When profit equals to zero. How many heads? Who wants to answer? How to solve this? Ivan, please.
So our total revenue should be the same as the total costs, and we make these functions equal, like 20Q is equal to 15Q plus 1,000. And then we count it's 5Q, 1,000, and it's 200 heads.
Yes, yes. So in this point, total revenue equals to total cost when quantity is equal to 200, and the profit here will be zero. Yes. So in this point, profit equals to zero. So let's write down. Profit is the difference between total revenue and total costs. Yes, it's the profit. And we should make it zero. So total revenue should be equal to total cost, and equalize it. 20Q should be equal to 15Q plus 1,000. 5Q equals to 1,000. Q equals to 200. So when we sell such quantity, profit equals to zero. Yes, thank you. Then, is the behavior of these firms' average variable costs consistent with the law of diminishing returns? This I want to explain to you because I think it's not too easy. What we remember about law of diminishing returns? Remember that it is when the amount of input increases, the marginal product out of this input decreases. Yes. Here we have only one variable product that we can change, it's labor. So for our task is this law is if we increase the number of workers, marginal product of labor will decrease. Yes, the last worker will produce less than the previous one. Yes, so we need to understand this how to say, how marginal product of labor and average variable costs, how they are connected with each other. So let's see. What we know about average variable costs? It's variable costs over quantity, yes? And here in our task, variable costs are only for payment salary for paying salaries to workers, yes? Only one variable input. So our variable cost here is wage multiplied by the number of workers over quantity. Agree? Then we can notice this one. What we know about this thing? Quantity over labor, it's total product over labor. It's average product of labor. So this is wage over average product of labor. Revert this. And what we also know for our function, that average variable costs are equal to 15. Could you, can you calculate marginal costs? Marginal costs for our function. It will be equal to what? Calculate marginal costs for me, please. Did you say?
I guess it's 15 or MO. Because we
15.
should take the because we just
Yes,
have
yes,
to
yes.
take derivative.
Take the derivative out of total costs, it's 15. It's the same as average variable costs. Yes, constant. So we pay to work, each additional worker will increase our costs by 15 by constant, yes, wage. Yes. So this is also 15 is also marginal costs. And marginal costs we can connect with a marginal product of labor. So average variable we can connect with average product of labor, and marginal costs we can connect with a marginal product of labor. So let's see. Marginal costs are, as you remember, the change in variable costs when we change the quantity. Do you remember this thing? So it's, for example, wage multiplied by the number of workers L2 minus wage multiplied by L1 when we change the number of workers over the change in quantity. So you see wage is the same, it's constant. So wage multiplied by the change in labor over the change in output. And you see that this is reverted marginal product of labor. So marginal product of labor, we know it's the change in quantity over the change in labor. Or we wrote also the change in total product by the change in labor. It's the same. Total product and quantity, they are synonyms. Okay. So this will be wage over marginal product of labor. So now we can make conclusion. So in our task, wage over marginal product of labor equals to 15. Yes. So marginal product of labor equals to how much? Wage over 15. Yes. And it's constant. Wage is constant. Yes. So everything is constant. So when we increase the number of workers, marginal product of labor stays constant. So here in our task, law of diminishing returns, we do not have here law of diminishing returns. But it was easy to understand because each additional worker increase our costs by the same $15 that we spent on wage, to pay wage. Yes, so, and that's all. Okay, please, questions about this. These formulas are in textbooks. In each textbook, you can find this connection. So, okay.
Can I ask a question?
Please.
Isn't the marginal cost and also like it equals to price, and it should be equal to marginal revenue from the lecture? We said that for perfectly competitive firms, I mean markets, if for profit maximizing, it was like in the last, I mean, slides, it should be equal to marginal revenue. Yes?
For perfectly competitive firm, marginal revenue, what that means, change in total revenue when we change the quantity that we sell, equals to the price, to the constant price. Because I don't know, you sell one banana, you get $5. You sell two bananas, you get $10. And the marginal revenue is always 5. It's the price of the banana, yes? And yeah. When we maximize the profit, one condition for this is that marginal revenue, always marginal revenue should be equal to marginal costs. And in perfectly competitive market, marginal revenue equals to price, So the price should be equal to marginal cost. But we will speak about this later. Okay?
Yeah, thank you.
All right, okay. So next. Mhm. Here we write not consistent with law of diminishing returns. And C. When C, if this firm seeks to maximize its profit, how many heads should it produce? To maximize profit, how many heads should it produce? Equilibrium quantity. Maxim, please.
As I understood it, as you told a minute ago, to maximize profit of firm, the marginal revenue should be equal to marginal cost. And in that case, this firm will be able to sell amounts of any output at a given market price P. And or not.
Let's see.
Okay.
If marginal revenue here equals to 20, yes, and marginal costs here equals to 15, and 20 is never equal to 15, yes?
So it's not a perfect competitive market?
It's perfectly competitive market, but we have a different profit structure, yes? Let's see. Why here marginal revenue equals to marginal costs that does not work, this rule. First, what we should do, we should write down the profit. Profit, one more time, it's total revenue minus total cost. Put here your functions, 20Q minus 15Q minus 1000. This will be 5Q minus 1000. And this we should maximize by choosing quantity greater or equal than 0. What do you know about such function, this profit function, 5Q minus 1000? It's linear function with positive slope, yes? And when it will be maximized? With positive slope, it will be maximized in infinity, yes? So we can increase quantity and get more and more profit, yes?
Until our maximum of quantity.
Yes, so we stop here. We cannot sell more than 1000. And that's all. This is our answer.
Okay.
For linear functions, we should check this, how to name them? Угловые решения, corner solutions. We should check. So what we say, profit increases with quantity increases as linear function with positive slope. That's why our optimal quantity, how much to sell, equals to maximum that we can sell, equals to 1000 in this task. So if in profit you get linear function, you should do like this. If you have quadratic function, you should do marginal revenue equals to marginal cost. And also we can calculate this profit. Maximal profit will be put 1000. How much? 4000, yes? And on the graph where I draw this profit, total revenue minus total cost is the difference between two graphs, yes? Maximal difference is here. Yes, this is maximal profit. You see? So this is maximal profit. When we produce less than 200, total costs are higher than total revenue. So we have a negative profit, yes? We have losses. And when we produce 200, profit is 0. And then this difference between total revenue and total cost, it increases, increases, increases. And this is the maximal that we can get. Okay, so that's all about this task. I erase. While I'm erasing, please ask questions about this. And we continue. Number 2. It's theoretical thing from the lecture, number 2. Sidorov and Sons Corporation has a production function displaying increasing returns to scale in the output range 0 to Q1. So increasing returns to scale when quantity from 0 to Q1. Then constant returns to scale when quantity between Q1 and Q2. And decreasing returns to scale if quantity from Q2 to plus infinity. Point A. We should illustrate the firm's long run average cost structure. Long run average costs on the graph. What is the relationship between the long run average and long run marginal costs at the level of output between Q1 and Q2? So, okay. How to draw long run average costs? How to connect it with returns to scale? If we have increasing returns to scale, what that means? You remember, if we make capital and labor, for example, 2 times bigger, yes, the production, the output becomes more than 2 times bigger, yes. So, Ivan, you want to explain, yes?
If returns to scale are increasing, then the average cost is diminishing.
Yes, yes. So it's cheaper for us to produce. Next.
For every single good, it's getting cheaper to produce.
Yes, yes. So average costs, long run, decreasing. When we have constant returns to scale, what we can tell?
We reach the minimum point, like the minimum point of average costs.
And long run average costs, they are constant. Yes?
Yeah, they are constant.
And the decreasing returns to scale, they are increasing. Easy. So let's draw like this. So from 0 to Q1, then to Q2. Between Q1 and Q2, we will have constant part. Yes, long run average costs are constant. Then here will be a decreasing, and here increasing. Yes, so also how we name decreasing long run average costs. Maybe you know this, but maybe not.
Yeah.
When
We know it from the lecture. We know it.
How to name? Please, Anastasia.
So it should be economies of scale.
Yes, yes, it's.
And
here.
while decreasing, it's diseconomies of scale.
Economies of scale here, and here these economies of scale. And here constant economies of scale, but it's not interesting. These economies of scale, good. Then next, assuming that the firm's short-run average costs curves are U-shaped, add several short-run average cost curves to your graph from A. Okay, let's add. Short-run average costs, U-shaped. Okay, let's put over here. short-run average cost 1. Here will be short-run average cost 2. And here will be short-run average cost 3. Please notice then that when we have economies of scale, this short-run average cost function, it touches long-run average cost, not in minimum. Minimum is here, yes, but and it touches long-run average cost here. You see? Please notice this. Then, when constant economies of scale, yes, here it touches in minimum, easy. And short-run average cost, when these economies of scale, it touches to the right to minimum of short-run average cost. Okay. Then. For each short-run average cost curve, you add it to your graph from A, and there's respective short-run marginal costs. What we know about the connection between average costs and marginal costs? One more time. They where they intersect each other, marginal costs and average costs.
Minimum.
In minimum, yes. Okay. So that's it. Marginal costs. Another. Marginal costs 1. Here, marginal cost 2. And here, marginal cost 3. Then, also, I think we should draw long-run marginal cost. Let's see. It's for short run, everywhere as short run. Do we need this? Long run marginal cost at levels of output between Q1 and Q2. We didn't answer about this. So, but you are, no, you didn't answer about this. If we have, it's from point A, our question. If we have long run average costs constant, what you can tell me about long run marginal costs? What means long run average costs are constant? Yes, that we produce each unit for the same cost. Yes, on average. Ivan, please.
So
What about
marginal cost is 0? No. If we don't change the cost for each good.
It changes the average costs are constant. Total costs, they are increasing.
Yeah.
So long run marginal costs, they are equal to long run average. Yes, they are constant. And that's all. What means marginal costs? It's how much the next unit produced, the last unit produced, how it increases our total costs by the same sum as previous unit, and that's all. They are constant. So let's draw long run marginal costs. So they will be the same as long run average when we have constant economies of scale or constant returns to scale. Then, what about long run marginal cost when we have when we have economies of scale here? They will be higher than long run average all over. We have economies of scale. Please answer. Who know?
Low, they will be lower.
Lower, yes. So they will be lower, and also they should intersect. I should draw carefully. They should intersect short-run marginal costs when we have this touch. Let's see. Costs. Yes, here. Marginal cost should be this. Mm. Something like this, but they rise lower and they are decreasing in this point. And when we have these economies of scale, marginal costs, long run marginal costs higher than long run average costs, and they also intersect short run marginal costs. Here. Like this, in this point. This is long run marginal costs. Let's write down. That when economies of scale long run marginal costs lower than long run average costs for each Q, for each quantity. When these economies, vice versa. Like this. You proved it in the lecture, but I don't want to prove it right now because we don't have a lot of time about this. And also, let's write down that long run marginal costs equals to short run marginal cost 1 in, for example, in this point, let's say that it is QA, for example, in QA. Also, long run marginal cost equals to short run marginal cost 3, yes, in here, in QB. Why is it so? Because in long run, we have a lot of time to change all our resources, and we take the minimum. Yes, we take the lower envelope of all short-run average cost functions. Because this short-run average cost 1, average cost 2, average cost 3, it's they are all for different amount of capital. This for one machine, this for 2 machines, this for 3 machines. But in long run, we can switch from 1 machine to 2 machines. Yes, that we cannot do in the short run. That's why when we go to long run, we take the lowest costs. Yes, and when we draw the marginal costs, yes, in the short run, in the long run. In the long run, for example, consider short run average cost 3. We will take this point, the lowest point, yes, when here touch, yes, the lowest touch of short run and long run function. We will take this point, and we know that in this point, we will have some marginal costs. Yes, that's why if we took short run average cost 3, marginal cost will be equal to this. And we took it in the long run. That's why in long run, we will have the same marginal costs. That's why they will intersect in this point, in the point of touch. So it's not, I think it's very hard topic to understand. That's why you heard it in the lecture, you heard it right now. Please read it in the textbook and then repeat and something like that to understand. Okay, so you can rewatch our class because I'm recording it. Okay, so let's continue. And I think we will do the last problem, number 3. Mhm. So the Smatra Racing Company modifies the engine controllers on standard, oh my God, on standard ladder cars so that they can do 0 to 100 kilometers in 10 seconds. Another company supplies the Smatra with details needed to the modification and then pays $10 for each modification done. So the price equals to $10 per modification. The Smatra's only factors of production are its employees, labor, and a small garage with a specialized programming and diagnostics equipment. It's capital. Yes. The number of cars it can service per day depends on the number of employee hours per day as given in the table below. So let's draw this table. Cars, its quantity, 0, 5, 10, 15, 20, 25, 30, 35. Number of employee hours per day, it's labor, 0, 1, 2, 4, 7, 11, 16, 22. Then we should find fixed costs, variable costs, total costs, average variable, average total, it's average costs, and marginal. What information we also need? We know the number of workers, we need the wage, how much we will pay. Point A. Suppose that the workers are paid $10 per hour. So wage equals to 10. And the fixed cost for the garage and equipment is $60. It's that's why we know that capital is fixed here. Yes, garage, one garage. Fixed costs for garage is $60. First question: is it short run or long run? Please, somebody. Елисей.
Short run, I guess.
What?
It is short run because we have only one factor of production that we can change. And the second, sorry, I don't understand why we would have dollars per day in fixed cost. How are we supposed to know how many days we have? Or we just have $60 in this short column.
Yeah, so we're speaking about short run because we have fixed costs. That's why we have some fixed input, yes, capital. That's why fixed costs are equal to 60. And here everywhere is 60, 60, 60, 60, 60, 60, 60, 60. Then about variable in total, who wants to fill in variable costs in total? Maybe somebody else? Maybe somebody new? No? Okay, Елизавета, please.
Okay, I will try. Variable cost, if there is only one, first, when there's no workers, when labor is 0, then variable cost is 0. When one worker, it becomes 60. Oh, no, not 60, but 10.
10, yes, because variable is wage.
It's wages.
So then?
Then 2 is 20. Then 4 is 40.
40,
70.
Easy.
7, yeah.
Here's 0.
Yeah, and 220.
Total?
Total is at first 60. Yeah. Then 70. 80. 100. 130. 170. 220. And 280.
Yes, thank you. So we how to find total? We should sum up variable and fixed, and that's all. Average variable and average total. What we should do? We should divide by the quantity. Yes. Okay, it's easy, so I will not ask. Let's fill in it fast. So average variable over quantity. So you see not labor, but quantity. Here is the point, yes. And average is total by quantity. So average variable are 0 if quantity is 0, and average cost is 60 over 0 plus infinity. Yes. Then average variable equals to 10, quantity equals to 5. So it will be 10 over 5. So and average 70 over 5. Okay, who wants to help me? Maxim?
14, 71.
14, yes. Then here 20 over 10 it's 2, yes, and 80 over 10, 8, yes. Then 40 over 15, it's 8 over 3, yes. And 100 over 15, it's 20 over 3. Then 70 over 20, it's 7 over 2. 130 over 20, 13 over 2. Here, 110 over 25. Okay.
Can you be a bit slower, please?
Yeah, we only calculate these formulas.
Yeah, I understand, but I just don't want just copy what you are writing. So I'm trying to calculate, and it's so quick.
But if we will stop, we won't have time to finish the.
I wanted to show you the graph because I made it in Excel. I wanted to show you the graph. So here put 25. So it will be 4.4. Here 6.8. Here 5.3. Here 7.3. Here 6.29. Here 8. And about marginal we know that when quantity is 0, we do not start to change quantity. So here we do not calculate it. Then we work by definition. Marginal cost is the change in total cost when we change the quantity. Yes. So let's calculate marginal cost when we make when we make fifths of 5. It's an interesting question. When we make fifths, it's fifth of 5. So no, 5. How our total costs have changed? Now it's 70, before it was 60. And the change in quantity, we had 0 and now we have 5. Yes, the change in quantity 5. 5 minus 0. So it will be 2. You see 10 over 5, it's 2. Then let's calculate marginal cost out of 10. The change in quantity from 5 to 10. So we should divide not by 1, but by 5. The change in quantity, 10 minus 5. And the change in total cost, 80 minus 70. It's also 2. Yes. Marginal cost when we produce 15. We now have costs 100. Before we had 80. And the change is 15 minus 10. Change in quantity 5. And this will be 20 over 5 is 4. Yes. So here 2, here 4. And you do like this with this method, filling all this column. 4, here it will be 6, here will be 8, here will be 10, here will be 12. Then, okay, I don't have time to show. Okay, it will be the homework for you. And we will check the next time. Construct in Excel this table. Draw the graphs of fixed, variable, total, average, variable, average cost, marginal cost, as in the task. Try to construct in Excel by yourself with these numbers, and also the price. Plus the price equals to 10 always. And you will see where price will intersect marginal costs and where we will have maximal profit. But you know where it will happen, yes? You know, for profit maximization, one of 3 conditions that should happen for profit maximization, marginal revenue should be equal to marginal costs. Yes, it's only one of 3 conditions. But marginal revenue here is the price for perfect competition. So a price, we know that it's equal to 10 from the task. So where marginal costs equals to 10 here, yes? So we should produce 30, or 30 units, yes, of our work to maximize profit. But you can calculate by yourself also. In the table, you can calculate total revenue, and profit, next column, and check yourself. Calculate here total revenue also and profit. You know how to calculate total revenue? Quantity multiplied by the price 10. Easy. And then how to calculate profit? Revenue minus total costs. Also calculate and choose the maximal profit from this table. And you will see that maximal profit will be here in this row, in this line. So this for you, and we will check it the next time. I will show you my graph. You will show you will say yes. So we also have a graph like this or not. Okay, guys, can I check who answered today, please? It's Иван Замковой, yes, Максим Никитин, Елизавета Головцова, Елисей и Настя. Правильно? Все. Елизавета я сказала.
Да, я просто, мне связь отстает.
Да, все, я вроде всех записала, никого не забыла. Вот, но у нас одни и те же отвечают. Ребята, я все время жду, когда, может быть, кто-нибудь еще руку поднимет.
Можно вас попросить просто, вот, то, что я уже говорила про скорость, я понимаю,